So we will now look at some example problems on the topics of summation that we've been looking at in the previous videos. So these example problems will be from the AMC, which are the American Mathematics competitions. And a lot of high schoolers participate in these competitions, and they use the methods that we've described in the previous videos for some of the problems in very creative ways that aren't like just a plain substitution. They usually require some extra creative thinking. So let's start out with 2010 AMC 12B problem number 10. So they're asking us the average of the numbers from 1, 2, 3, all the way to 99, and x. So x is one of these numbers over here. The average of those numbers is 100x. What is x? So the way we can think about this is the average of any set of numbers is the sum of all of those numbers divided by the number of numbers. So this would be the sum of 1, 2, 3, all the way to 99 plus x over 100, because there's 99 numbers from 1 to 99 inclusive, and then the 100th number is x. So we already know that we have to add up 1 to 99, and we know we have a formula for that since it starts at 1 and ends at 99. And that formula is n times n plus 1 over 2, where n is the number of numbers that we're using here. So number of numbers in this case is also the last number, so 99. So what we have is 99. If we substitute that for n, 99 times 99 plus 1 is just 100. 99 times 100 over 2, which is also 9,900 over 2. And 9,900 over 2 is basically like 99 over 2 with an multiplied by 100. So, and 99 over 2 we know is 49.5. So if we multiply that by 100, this is equal to 4,950. But remember, we're not just averaging the numbers from 1 to 99. We're also keeping x as one of the numbers in those average. So what we're actually looking at is the 4,950 that we got before plus x. So the 4,950 plus x are the numbers that we're averaging. And of course, we have to divide this total sum by the number of numbers, which is the 99 numbers here, plus x, the 100 numbers, so there are 100 numbers. And this is equal to 100x. This entire average is equal to 100x. And we have an equation with one variable, so it looks like we should be able to solve this. We'll multiply the 100 to both sides, so we'll multiply 100 here, and that 100 cancels with this. But we also have to multiply 100 to this side, so we're going to multiply 100. And from this, we are left with 4,950 plus x is equal to 100 times 100 is 10,000. 10,000, and now, 10,000x. And now we can solve for x by bringing the x terms all to one side. So we'll subtract an x on both sides. And when we subtract an x on both sides, on this side, we'll be left with 4,950 is equal to 9 9,999x. So 9,999x. Now this doesn't exactly look like the answer choices we have here, but we're pretty confident that we've done the right things. So we'll still keep solving for x and see if maybe we can simplify some things. So what we can do in this case is we can divide by 9,999 on both sides to isolate this x over here. And of course we have to do that to both sides whenever we're solving an equation. And from this, we are left with x is equal to, I just flip the x over here because usually you have the variable that you're solving for on the left side. So this 9,999, this one, these two cancel out, and we are left with 4,950 over 9,999. Now, let's see, how can we simplify this? Well, 9,999 looks very divisible by 9, and if you know your divisibility tricks for this, we know that we can test for divisibility by 9 by seeing the sum of the digits. And if you don't know that, it's okay, but I recommend you search it up. It's very useful in these cases when you're trying to simplify fractions. So you just take the sum of the digits, which in this case would be 4 plus 9 plus 5 plus 0. And 4 plus 5 is 9, plus 9 is 18, plus 0 is still 18. And we check that sum and see if that sum is divisible by 9. And since that sum is divisible by 9, we know that 4,950 is divisible by 9. And this is a very useful thing to know here. So I'm going to do the work required for that over here. So 4,950, and we're going to divide that by 9. So 9 goes into 49 5 times. So we have a 5 up here, and we have 45 down here. And we're left with 45, and 9 goes into 45 5 times as well. So we have 5, 5, and the 45 again. That's a 0, and 0 times for the 0. 9 goes into 0, 0 times. So we're left with 550. And when we divide 9,999 by 9, we're just left with 1,111. So we know that this simplifies further to 550 divided by 1,111. Now, 55 is a repeated digit, and this number 1,111 looks just like two 11s. So I'm thinking, like, the signal goes off that, whoa, they're probably both divisible by 11, and they are. So I'll move over here just to get some space over here. So 550 is divisible by 11 in that you can just multiply 5 times 11 is 55, so 50 times 11 is 550. So if we continue over here, x is equal to 550 over 1,111. And if we divide both by 5, if we divide both the numerator and the denominator by 11, they cancel out, and that leaves us with 50 out of, and then dividing the denominator by 11 is 101. And we see that that leaves us with choice B. And we can move on to the next example problem. So this problem is the 2020 AMC 10A, problem number 8. So that's actually this year. So they're asking us to find what is the value of 1 plus 2 plus 3 minus 4 plus 5 plus 6 plus 7 minus 8. And that pattern continues. Every multiple of 4 is actually subtracted instead of adding. You would think it would be adding based on the other numbers, but Every multiple of 4 is subtracting. So how can we do this? Well, since this reminds us definitely of just a normal sum with all positive numbers instead of these negatives in here, we want to try to figure out a way to write this as maybe the sum of the numbers 1 to 200 minus some numbers that'll maybe give us the -4, -8, and maybe that'll be a sequence. So let's first think about that. So if we have 1 plus 2 plus 3 plus 4, and remember, we're just doing the normal sum, not this one. This one has a -4, and this goes on plus 197 plus 198 plus 199 and plus 200. So in order to get these negatives that we want over here, we need to subtract something from every fourth term. So how can we do that? Well, to get a -4, what do we need to subtract from this 4? Yeah, so we'll have to subtract a negative. We'll have to subtract 8 from this 4 over here, which is also the same as subtracting 8 from this entire thing. Because remember, this is all just a summation. So this is one number over here. So we're essentially just subtracting 8 from this 4. And we have to do that for every multiple of 4. So for the -8 over here, what do we need to subtract from the +8 in this sequence to get the -8? So yeah, we need to subtract the 16. So when we go all the way to the 200, we want -200 instead of +200. So we want to subtract 400. And you may see a pattern because we're just subtracting the double of the number, the double of the multiple of 4 that we have over here. So now that we have a general idea, so let's think about it. So we're just doing -8, -16, and something like that, -16, and then this is another multiple, a double of multiple of 4 over here. So we need to add first all of these from 1 to 200, and then subtract these extra ones, these -8, -16, -400. So now that we have a general picture, let's just use our handy formulas to sum from 1 to 200. So we know that that is, again, n times n plus 1 over 2, since the first term is 1 and the common difference is also 1. So in this case, n is 200. So that'll be our n. So we'll substitute that 200 times 201, because n plus 1. And we divide that by 2, which is also just equal to 100. This is just equal to 100 times 201, which is just 20,100 if we multiply it. Just put the 2 zeros on at the end. So it's equal to 20,100. Now obviously this isn't one of the answer choices here, but we know that that's because we need to subtract these -8, -16, all the way to -400. So how can we do this? So let's write this out more clearly. What exactly are we subtracting here? So if we write that over here, we're actually subtracting -8 -16 -24, because we have a common difference of 8, -8 actually, to be more precise. And this goes on all the way until -400. But this isn't, we can use our other formulas for the first term, last term, number of terms, but I do want to show a creative way to think about this. Since they're all multiples of -8, we could just factor out -8 from this entire thing. So when we factor out -8 from this entire thing, we're left with 1, plus -16 divided by -8 is 2, -24 divided by -8 is 3, and we see what's going on here. And this will go on until negative 400 divided by negative 8, which is 50. Which is very interesting, because now it's much clearer what we can actually do to this. We can turn it into this n times n plus 1 over 2 formula. So that's what we'll do. Turn it into n times n plus 1 over 2. So remember, we still need to have the negative 8 on the outside, but this will be multiplied to, n would be 50 in this case. So 50 times 51 over 2. 50 times 51 over 2. Now this 2 and this 8 will become a 4, so this, because they cancel, one of the factors cancels each other out. So this just becomes negative 4 times 50 times 51. And that's also negative 200 times 51. So negative 200 times 51, which we can just attach the negative on later. So 200 times 51 is just 2 times 51. It's just 2 times 51 with 2 zeros added onto it. So we just have 2, and we have 2 times 5 is 10. So 102, but remember we're multiplying it by 200, not 2. So we're actually left with negative 10,200, because we had to add the 2 zeros on. Now how do we put these together? Well, as you can see, we're just adding this original sequence of all positives to this negative sequence. We're still adding, we're adding the negative sequence to the positive sequence. So we're adding the sums of both, which we have for both of them. So we have 20,100 plus negative 10,200, which we see is 9,900, which is B. And we can move on to the next question. So this is an interesting problem from the 2012 AMC 12A problem number 7. And we have Mary divides a circle into 12 sectors. So let's imagine that. So we have some circle over here. I'm just sketching it just to see what they mean. But 12 sectors. The central angles of these sectors, measured in degrees, are all integers, and they form an arithmetic sequence. So what does this mean? This just means we have the center over here, and we have some sector that's like this, and a sector like this, and a sector like this, and they gradually get larger and larger. So the angles of the sectors get really large. So this one starts maybe at like some small amount. This one is larger. This one gets even larger. And as we can see, we get this idea. It's kind of like a shell. It gets larger as it gets to the outside. And this forms an arithmetic sequence. So the moment we read the words arithmetic sequence, we should realize that we're probably using some of the ideas or formulas that we know. What is the degree measure of the smallest possible angle measure? So they're asking, what is the degree measure of this smallest sector right over there? Now I know this is not 12, but this is for the general idea. So let's think about it. First, let's figure out what the central angles of these sectors all have to add up to 360, since they're all in a circle. So that's the first thing we'll do. We'll put something equal to 360. We know we're gonna have the sum of all of these central angles equal to 360 because it's in a circle. Now let's see, they're all measured in degrees and they're all integers, so we're probably gonna do something with these integers, and they form an arithmetic sequence. So since we see arithmetic sequence, I think we should use a general formula. We don't know what the first term necessarily is, and we don't know what the common difference is necessarily either. So I think we're going to use one of the more general formulas that we derived, which is the n over 2 times 2a plus n minus 1 times d. And remember, this may look like a very weird, complicated formula, but it's just the first term plus the last term, which in the videos we derived is this 2a plus n minus 1 times d, times the number of terms over 2. So can we fill in anything already from this? Well, let's see. Mary divides a circle into 12 sectors. So we know that there's 12 sectors, meaning there's 12 central angles. And since we're summing all the central angles, that means the number of central angles is also n. So this n actually just becomes 12, and we see there's another n over here. So we're actually left with 6 times 2a plus 11d is equal to 360. See, what can we do? Well, we can simplify things somewhat. So we have 2a plus 11d is equal to 60. Interesting. So, what can we do from here? Well, let's see what they're asking again. We need to see any ideas we can do. Well, we notice that they're all integers. All of these are integers. So that means that whatever this 2a is, when we bring it to the other side, when we do 60 minus 2a, that means the common difference must also be an integer. Because you can only get, if you start with an integer and add an integer, that's the only way you can get an integer. If you add a decimal, if you add part of an integer, then you're going to get some integer plus decimal, which is just a mixed number or fraction. So we need 11d equals 60 minus 2a. I just brought the 2a to the other side, so I subtracted 2a on both sides. So 11d is equal to 60 minus 2a. So let's write this. Let's do one more simplification for solving for the common difference. So 60 minus 2a, and I divided by 11 on both sides. 60 minus 2a over 11. In order for d to be an integer, 60 minus 2a divided by 11 also must be an integer, meaning that 60 minus 2a must be divisible by 11. So this is very nice, because now, since we have the answer choices, or even if we didn't have the answer choices, we should still be able to substitute numbers relatively quickly to figure out the answer. But since we do have answer choices, we can just substitute our answer choices in. Because remember, they're asking what is the degree of the measure, what is the degree measure of the smallest possible angle measure, which is also happens to be our first term, a, over here. So we have 60 minus 2, and first let's substitute 5. Let's substitute 5. So if we substitute 5, so I'm actually going to make some kind of chart for this. So we have, this is the A column, and this is the other column is the output. Well, let's name it O. So if A is 5, then we have 60 minus 10, 60 minus 2 times 5 over 11, so 60 minus 10, which is 50 over 11, which is not an integer, so we can eliminate that option. We have 6, which we can substitute. 60 minus 2 times 6, which is also 60 minus 12, which is 48. 48 over 11 is not an integer. So let's continue. 8. 60 minus 2 times 8 is 60 minus 16, which is 44. So we have 44 over 11. And that is an integer. That is equal to 4. So we know that 8, the smallest angle measure, if this was 8, for example, we would know that that would work. And that would be the smallest from the choices we have over here. So we can be confident we selected 8. And if you don't understand this exactly, just try to realize. So I'll try to give an overview of this problem. So basically, we used the sum formula, summing all of these angle measures of these different parts of the circle over here, and there are 12 of them. So since there are 12 of them, we substituted 12 for n in this formula over here. And since it was a circle, they all add up to 360. We simplified a bit of things over here, And then we realized that in order for D and A to both be integers, when we substitute A, some value for A as an integer, D must be an integer, meaning 60 minus 2A must be divisible by 11. We then just tried out these different values, and we were able to realize that 8 is the smallest value that works. So that's choice C, and we have completed these example problems. I hope you learned not only how to just know these formulas, but also how to apply them in creative ways and using different thought processes than we used in some previous videos. So I hope you enjoyed.